Hi physics fam, we are going to do a horizontal projectile problem where we are determining how far an object will fly horizontally before it strikes the ground. So we have an arrow fired from a bow with a perfectly horizontal velocity of 60 meters per second. So we have our bow here, and we have a horizontal initial velocity in the x direction of 60 meters per second. And we know that its initial position is 2 meters. And we want to know how far it's going to fly horizontally before it strikes the ground. So we know that its final y position is going to be 0 meters. And this arrow will at some point hit our final x position. We can also list our initial x position as 0 meters. So now that we have a drawing of sorts, we can go ahead and make our t-chart. So we have the x and the y side here. We have an initial x position of 0 meters. Our initial y position we said was 2 meters. Our final position is what we're solving for, but in the y direction, we know that that is going to be 0 meters. Then when we look at our acceleration, in the x direction, we have 0 meters per second squared because nothing is impacting the motion horizontally. In the y direction, we have acceleration due to gravity, so negative 9.8 meters per second squared. And then we have initial velocities. So in the x direction, we know that it's perfectly horizontal at 60 meters per second, and that means that in the y direction, it is 0 meters per second because it's perfectly horizontal. Then in our x final velocity, that is also going to be 60 meters per second because we are looking at there being no change in velocity, and we don't know what that is in the y direction, so we'll just list it as Vy for right now. The next thing that we don't have is time, but we do know that it is the same in the x and the y direction because it's referencing the motion of the object the same way. So if we go through, we're trying to solve for x. When we look at all of our kinematic equations, we realize that we can't exactly find x without using time. So we need to find time, and we're going to be able to do that in the y direction because we do have enough information in the y direction. So I'm going to go ahead and get rid of our drawing now that we are set. So if we use the equation that says y equals y initial plus initial y velocity times time plus 1/2 acceleration in the y direction times t squared, we can go ahead and find the time and use that in the x direction to find our x value. So we can plug in all the information that we have. Our y final position is going to be 0. Our initial y velocity is also 0. So we can go ahead and write 0 equals 2 meters. And then we have 1/2 times our negative 9.8 meters per second squared. And then we're solving for time squared. So we can go ahead and I'm going to move this 2 over to the other side. And then we have negative 4.9 t squared on the right side. We can get rid of our negatives now. And we will do 2 divided by 4.9. So we'll end up with 0.408 equals t squared. You can round differently than I did if you would like. That's how I'm going to write it. And then when we take the square root, we have 0.639 seconds being time. Typically, I actually round to 2 decimal places, but both answers are correct. So that's our time. But just keep in mind that that isn't what we're solving for. We are using that time to now solve for our x position. So if we use that exact same equation, we can now solve for our x position. So we could use this, or we could recognize that our velocity is constant, so we can use our average velocity equation using delta x over delta t. We will get the same thing regardless of which equation we use. So it's up to you how you want to write it. We can go ahead and put in, move the time over to the other side so that we can solve for delta x. And then our velocity was 60 meters per second. This is occurring over a time period of 0.64 seconds to solve for our change in position. So we should end up with a horizontal distance of 38.4 meters from where the bow originated.